Hello, this is our video for our AC circuit team project.
Hello, my name is Jorge Mercado and I will be doing the multi-sim part of the project.
My name is Rachel Lugo and I'll be doing the old school bench part of our project.
Hi, my name is Enrique Mendez and I'll be doing the new school bench part of our project.
So I'm going to be doing the multimeter side of the project on Multisim, and I'm going to start by bringing in all of my components that I'm going to be using. And to start, I will bring in the power source. For that, I will use the AC power. And I'm going to change the voltage to 1.9 and my hertz to 500 hertz. Also gonna label it voltage N. And I'm gonna need a ground, which I'm gonna find. You can find that on also on sources. So I'm gonna bring in a ground, and I'm gonna be using two resistors. The first one is gonna be 1.5 kilo ohms. And my second resistor is going to be 2.7 kilo ohms. I am also going to use two voltmeters, indicators. I'm going to relabel them. Voltage pin, RMS, and voltage 2, RMS, and they have to be changed to AC from DC. I'm now going to make my connections. There's also one more component I'll need, which is the oscilloscope. I'm gonna rotate my resistor 90 degrees. I'm gonna make that connection. I'm going to change the color of my ground black. I'm going to connect voltmeters. And I'm also going to connect my oscilloscope. So now that I connected my two channels, I am going to collect measurements, and for that I'll need to turn on the circuit and stop the circuit. I'm going to open my oscilloscope, and I'm going to change my scale. And per division, hopefully I'm going to change them to 1. So I'll have a better display. And first I am going to put it on AC, channel A, which is voltage N, and I'm going to calculate peak to peak. And my voltage peak to peak for channel A, it's 5.36 volts. I'm also for channel A, I'm going to demonstrate how to collect my period, and you can do that by going here and setting it to 0. And it's going to be so for channel A, my period is 2 milliseconds. Now I am going to demonstrate how to measure peak to peak on channel 2, on channel B. So I'm going to turn on the AC on channel B, and for channel B, the measurements for peak to peak voltage is 3.44, which is located right here. And now I'm going to be demonstrating the period for channel B. So for my measurements on channel B, it's also 2 milliseconds. And I am going to demonstrate how to get the frequency. I'm just going to, for frequency, is 1 over my period times 10 to the minus 3 is the conversion to, so I can have my answers on hertz. 1 divided by 2 milliseconds times e to the minus 3 times e to the minus 3 which equals 500 hertz, which is what I have right here. And it also proves what we have initially, which is the 500 hertz. And I'm going to be using my voltmeters to calculate the RMS across my voltage in and B2. And for that, it gave me 1.9 across B1, B in, and 1.22 across B2. That's my RMS.
Okay, so this is the setup for setting our measurements on our function generator and oscilloscope and our DMM, so that we can set the correct voltage that's going to be put into our circuit. First, we're going to take the cables from our DMM positive and a function generator positive, match those together, as well as the positive from our oscilloscope probe. Then we're going to take the negatives from our function generator and the negatives from our DMM, connect those together, as well as the negative from our oscilloscope probe. Then we're going to turn on everything. And then we're going to look at our DMM, and we're going to make sure that's an AC. And then on our function generator, we're just going to make sure that our left knob is pointing straight up and down, and our right knob for amplitude is all the way counterclockwise. We're also just going to make sure all of these buttons are out position. We're going to make sure this is on the first one for the sine wave. Okay, and then we're going to use our amplitude to adjust our number for our voltage. We're also just going to make sure that this is in volts, so we're going to go all the way to the left until we see millivolts, then we're going to come back to the right. Then we're going to start adjusting our amplitude knob to get to 1.9, which is the voltage that we've chosen for our circuit. Okay. Then we're going to make sure our frequency is on the proper frequency, so it is on 500, and we're all good. Go.
So for our AC project, we're gonna set up our breadboard and our circuit. For all the cable plug-in, we're gonna start with the function generator cable. We're gonna put it in the amplitude. Then we take both our cables. We already set up our loose wires and then our two resistors. So resistor 1 is a 1.5 kilo ohms, and our resistor 2 is a 2.7 kilo ohms. We're going to take the positive and put it with the positive. We're going to put the ground and put it with the ground. Put it with the negative. Then we're going to take our DMM probes. We're going to put negative with negative, positive with positive. We're going to take our alligator clips. For positive, we're going to put it here in this loose wire, and then our negative, we're going to put it at the bottom of resistor 2. For our last probes, we're going to put in the oscilloscope probes. So we're going to put yellow to channel 1 on the oscilloscope, and then blue to our channel 2. We're going to take the yellow oscilloscope probe. We're going to put it at the left side of our resistor 1. making sure our resistor is inside the breadboard. And then our channel 2, we're also just going to put it on the right side of resistor 1. Then we're going to ground out both of our oscilloscope probes by the 2 loose wires here. This is all our cables set up for our circuit. Next step would be to actually turn on our multimeter, our function generator, and our oscilloscope. For our multimeter, we're gonna make sure we're in AC world in volts. For our function generator, we decided to do a frequency of 500 hertz. If this wasn't at 500 already, we would just mess around with the frequency notch, make sure it's set. We want to get it as close to as possible. For our multimeter, we decided to go with a 1.9 volt. If we needed to, if this wasn't already set, the way we could set it up is touching this little knob, and we could actually adjust where we would want it to. Then our oscilloscope, we would just do hit auto, making sure it's showcasing the right channels and it's working properly. And that's our bench setup. After all our cables set up, grounding all the cables and putting all our resistors and building our circuit and adjusting all the values in our DMM, our function generator, and turning on our oscilloscope, we're going to do the old school way on calculating VRMS, V peak to peak, and our time and frequencies. So in order to get our VRMS, we can actually see it here in the multimeter. It's the 1.9. In order to get V peak to peak, we'll actually start with our channel 1. So we'll just hit auto. And we'll high channel 2. And we'll adjust. So I'm gonna do our V peak to peak. So I'm gonna adjust it so one of our bottom peaks is lined up there, and I'm just gonna count out. So we have 1, 2, and 0.2, 0.4, 0.56, 0.8. So we have 2.8 for our VID, which is in our format for taking peak to peak. I'm gonna take that 2.8 times our voltage, which here in channel 1 is going to be 2 volts, and multiply it, and what I get is 5.6, and this is going to be our 5.6 V peak to peak for channel 1. Now we're going to go and get our period, so I'm going to set this to match here on the line, and now I'm gonna set this guy to match more up here, and I'm gonna count for 1 cycle, so from here to here, and it's gonna be 1, 2, 3, 4. That's our VID. So we're gonna take 4 times our time, which is gonna be 5,500 microseconds. And I'm gonna do 4 times 500, and it's gonna be 2,000 microseconds. In order to get frequencies, just gonna go and do 1 over our 2006. We're converting it from microseconds to hertz, and our hertz value or our frequency is going to be 500 hertz, which matches both our multi-sims and the original frequencies that we had inputted into the system. For channel 2, I'm gonna have to take the positive of our multimeter and I'm gonna move it and I'm gonna put it at the top of our resistor 2, and that will give us our VRMS 1.2 volts. I'm gonna go to the oscilloscope. I'm gonna just hit again auto. I'm gonna hide channel 1, and just like I did for our first channel, I'm gonna adjust the scale positioning. I'm gonna get my BID, which is 1, 2, 3. 3, 2, 4. So my BID is 3.4, and I'm gonna do my peak to peak. So we're gonna do that 3.4 times our voltage, which is 1. So 1. So it's gonna be 3.4 V peak to peak. And now I'm gonna do my period or my time. And we're gonna level this out back again to kind of that 0 mark. Making sure this is at the 0 mark, so I'm gonna look from here to here. And again, we have 1, 2, 3, 4. And that's just like the same one in channel 1, which is just our 4 times our time, 500. And this gives us again that 2000 microsecond. And in order to get our frequency, we're just gonna do 1 over 2006. And again, our frequency is gonna be 500 hertz, just as in channel 1. And that is our old school way of doing the calculations.
Alright, so we're going to be doing our new school measurements for our values on our oscilloscope. We're going to be taking the frequency, the period, the VN, and the VPP, which is V peak to peak. Alright, so to start off with, we're going to clear our measurements. We're going to choose which channel we're going to start with. We're going to start with channel 1, so we're going to turn channel 2 off. There we go. Then we're going to adjust our position on channel 1. We're going to bring the vertical position and the Y to 0. And then we're going to bring our horizontal position over. And if we need to, we can adjust our scale, but it seems fine for now. Then we're going to come over here, and we're going to hit our measure button. We're going to make sure it's on channel 1. Then we are going to hit our voltage. We're going to come down until we find our VRMS under the voltage tab, which is right here. And then we're going to click in on this knob. That should bring our VRMS measurement up, which is going to be 1.9, which matches our measurement in our multi-sim lab. And then we are going to come here again. We're going to hit voltage, and now we're looking for our VPP, which is our V peak to peak for channel 1. Click enter on our cursor again, bring the measurement up, and we're going to get 5.52 for our V peak to peak. Yep. And then we're going to come here again, and we're going to go to time, which takes over our X value axis. And we're going to go to our period. We're going to click on that. And then it should bring up our period, but we'll get to that in 1 second. We'll go back to our time, and we'll also bring up our frequency at the same time. And then to remove this sidebar so that we can see our values better, we're going to hit the on-off menu right here. So we have our period, which is 2.0 milliseconds. And then we have our frequency, which is 500 hertz. And the 500 hertz matches up with our original value for frequency that we had inputted, and it also matches up with the 2 per second that we recorded in our old school values. Okay. And that is how we do our measurements for channel 1. And now we're going to repeat the same steps for channel 2. So we're going to turn off channel 1 and turn on channel 2. And then we are going to measurement button, make sure our source channel is on channel 2. Come back to our voltage again. We're going to look for our VRMS one more time. Bring that up. And as you can see, the colors change. So for our graph, it coordinates to blue. So these yellow ones are for our other measurements for channel 1. We're going to go back to our voltage again. We're going to pull up our V peak to peak. We're going to go to our time, we're going to pull up our period, we're also going to pull up our frequency for whatever time to. And then we're going to remove the label again. So we have our V peak to peak, which is 3.52. Then we have our period, which matches up again at 2 milliseconds. And then we have our frequency once again at 500 hertz, which matches up with our original input value. And then to see multiple values, because we push our VRMS off the screen, we come down here, and then we hit display all. That should bring up our VRMS right here at 1.23 volts, which matches up again with our multi-sim measurements. All of our other values are also on here. We have our frequency once again. We have at 500 hertz, our period at 2 milliseconds, as well as our VPP at 3.52 and alternating. And those are how we take our new school measurements.